We finished our discussion of query optimization. However, there is still a lot more you can explore in this direction if you're interested. As we learned before, one such topic is adaptive query processing and optimization. As much as we try to optimize our queries, they may end up performing suboptimal when executing. Being able to update the plans if they do not perform well during plan execution is a complex process. You can explore more about this in adaptive query processing. Another interesting topic is multi-query optimization. Sometimes a batch of queries are submitted together to a database management system. A query optimizer in this situation tries to minimize the work across all the submitted queries. For example, it can find the sub-expressions shared among the batch of queries, evaluate them once, and reuse the optimization results obtained for all of the queries that share them. The tables that are shared among the queries can also enjoy a shared scan that pipelines the scan tables to all queries using them instead of reading a table once for each usage in each query. Parametric query optimization is another interesting topic to explore. Sometimes we cache query plans to reuse them again. When the cached plan is being reused, some parameters for it, for example, the constants in the comparisons, might be changed. For example, imagine we have a university database and assume a query that takes a department name and retrieves all the courses offered in that department. With plan caching, the same query plan can be used for different department names in different usages, provided as the constant in the query. Such caching is usable when the optimized query plan can be used without change for the new constant values. If the plan might be affected by the provided constant, parametric query optimization might be used. In parametric query optimization, a query is optimized without being provided specific values for its parameters. This makes the query space a little bit more general, but when the query plan is optimized, the optimizer can return alternatives based on the values of the parameter that can be applied when the parameter is available. Sometimes more relations are joined for the query than actually required. This happens more often when views are used for plan generation. For example, in the shown query, S1 and S2 are the same as S. Therefore, the join with both of them is redundant and one can be dropped. Another example situation that this might happen and the joins can be dropped early on are when the conditions are contrasting some table constraints. Join minimization was a topic of interest since early days of relational database management systems and are still explored. Last but not the least is the complexity of optimization for update queries. Updates include a selection and then an update using set clause. A problem, which is known as Halloween problem, happens when the update is performed when the selection is being evaluated. In this case, the update may in return affect the result of the selection. There are many situations that this might happen. For example, when correlated subqueries are involved in the selection. The core of the solution for this problem is based on separating the parts of the query that define the update target and those that perform the update. This is applied if the test shows the Halloween problem may happen. Update optimization can also be applied for batch updates.